Yes. Yeah, this is regarding the assigned number two of forget edge computing. Question number two, we have to demonstrate network slicing using any simulation like Cisco Packet Tracer. So I have used the Cisco Packet Tracer, and I have used the network slicing in terms of VLANs and the VLANs, different VLANs, and for the segregation, yeah, I have used the switches and the routers. The switches will help in making the intercommunication between the same VLANs, whereas the routers will help in communication between the different VLANs. So here you can see over here that I have used four PCs connected to the switch 0, and another four PCs are connected to switch another switch. But I have used one router over here. So the if you can see over here, like this PC, this PC1 is actually connected to the gateway with 15.1. So it is a part of 15.1 VLAN network, and this is also part of the another same 15.1 VLAN. Like these two are the part of same VLAN, whereas these are the 16.1. These are part of different VLAN, and this is 16 another part of another VLAN, and there are two. Similarly, 6 is a part of 15 VLAN 1, and this PC is part of VLAN 1, whereas 7 is a part of VLAN 2, and this is a part of VLAN another VLAN 2. So PC 3 to 7, 5 are part of same VLAN, whereas PC 0, 1, 6, and 4 are part of another VLAN. Now, with the help of switches, so PC3 and PC7 can communicate. If we try to use this terminal, sorry, we have to use some another thing. Like if we try to use the command prompt, because now we are having now if we want to ping to this 7 PC, which is having actually the IP of 23 16.23, so it will be able to we will be able to communicate 16.23. So you can see that these are able to communicate, even though they are part of same VLAN, but the router will not come into the picture because the switches are capable to communicate, broadcast the message within the same VLAN, and they are able to communicate. But if we try to communicate to the PC6, which is a part of 15.1 gateway VLAN 1, its IP is 15.13. 15.13. So here you can see that it took some time. Why it took some time? Because firstly, very first message, if somebody is not aware about the destination, it's the using of the FFFFF in the MAC address. So it's a kind of broadcast to everybody. So what happens in the data link layer, we are having the FFFF, so every machine should accept that message, and once it comes to the IP layer 3, when it's opened that packet and it sees, yeah, it's 192.168.15.13, the the machine which is having the same IP address, it accept that packet and responds back in that request with the its own actual MAC address. So in that way, the router is able to learn its ARP table, and it will update that IP against that MAC address. So after once it is having that entry, after that the PC3 is able to communicate with that machine, because router knows at what MAC address it has to forward that request. So you can see that for the sum of the messages, it give us the request amount, but once the MAC address is learned, you can see that all the three packets are reached. So this is the way I want to demonstrate from the very first ping, that communication between the same VLAN is able to possible because both the machines are actually the part of different switches, so they are able to communicate. Another is in different network, they are again the part of different switches, but because the router knows, so the gateway configuration is able to transmit the messages at that point. So this is how the network slicing has been done over here. So that's how I was able to demonstrate the network slicing in this. So this is the configuration which is available here, and this is how the interfaces are able to learn the MAC addresses, and that's how they are able to communicate. Thanks.